All right, everybody, good morning. I'm going to do a video explaining the unit circle today. So to begin, we're going to do a quick little review of special right triangles. Let me just make sure my camera is straight. There we go. So today we're doing the unit circle. And we're going to extend on that. And in order for us to do that, I got to do a quick little review on special right triangles. Okay, so with special right triangles, I got two of them. I got this isosceles triangle that has definition of an isosceles triangle is that the legs are congruent. If the legs are congruent, that means that this opening or this length here and this length here are identical, which then implies that the angle that creates that length are also identical. Triangle angle sum theorem says that the internal angles of a triangle must add up to 180. I already know this one's 90, and these two are identical, so therefore, these angles here must be 45 degrees. Because we already know radians, I'm also going to always label these according to both the and radian measure. So 45 degree is also equivalent to pi over 4 rad. Okay, so just making sure we recognize that. And remember that these special right triangles are going to be linked to the unit circle. So this means that my hypotenuse will always be 1. My hypotenuse is always going to be 1. Because that hypotenuse is going to be the radius of the unit circle. And as I explained in my prior video, the radius of the unit circle is always 1. Okay? So that's what I got for the first one. Let's see. Two identical sides. My hypotenuse is always 1. I'm going to use my good old Pythagorean Theorem to find the length of these two guys. So I know that I have a squared plus b squared equals c squared. And c is always going to be my hypotenuse. So my hypotenuse is 1 squared. I don't know what these are, but I do know that they're identical. So I'm going to leave them as x. So I'm going to call a x squared. And then I'm going to call b as well x. So that's going to be another x squared because they're identical. See, congruency marks is equal to 1 squared. X squared plus x squared gives me 2x squared is equal to 1. Divide both sides by 2. I have x squared is equal to 1 over 2. And now, inverse property of a square means I'm going to square root both sides. And by doing that, I cancel out the squares. So I have x is equal to radical 1 over radical 2. I cannot have a radical in my denominator, so I must rationalize that. That means I got to remove the radical. The only way I can remove this radical is by multiplying both top and bottom by radical 2. Again, I'm not changing the value of this ratio because radical 2 divided by radical 2 is just 1. So I'm just changing its appearance. So this is going to give me radical 2. Radical 1 times radical 2 is radical 2. Radical 2 times radical 2 is radical 4, which is just 2. So that tells me that this side is radical 2 over 2, and this side is radical 2 over 2, right there. Okay? So this is the 45-45 special right triangle. We recognize, again, hypotenuse is 1, and my legs are radical 2 over 2. It's an isosceles, therefore the legs are congruent. So moving on to the next one. I also have this other triangle. And this triangle, here, again, 90 degree. This one does not have congruent angles. So one angle is much bigger than the other, but it's still a nice little situation. So this one here is a 30 degree. So 30 plus 90 is 120. I need what else to give me 180? 60. So this is the 30, 60, 90 special right triangle. Again, In radians, this right here is pi over 6 rad. This right here is pi over 3. Again, my hypotenuse must be 1 because it's going to be the radius of the unit circle. So hypotenuse is always across from the right angle. So this homie is 1. Okay. Now notice this relationship here. What can you tell me about 60 and 30? There is a relationship of 2 or half. So one of these sides is going to have that relationship. The way that I always like to remember my 30, 60, 90 is that this 30, 60, 90 triangle across from 30 is always half. Across from 30 is always half. So across from 30 is always half. Okay, across from 30 is always half. We're going to figure out what this side is. So a squared plus b squared equals c squared. I'm going to use a as one of the legs I already know. So I'm going to say 1/2 squared. I don't know what b is, so I'm going to leave it as b squared. And I know that my c is my hypotenuse, which is 1 squared. So I now have 1/2 squared is 1/2 times 1/2. That's top, top, bottom, bottom gives me 1/4 plus b squared equals 1. So I have, subtract 1/4 to the other side. B squared gives me, now I'll do this so you can break it down. 1 is the same as 4/4 minus 1/4. So I have b squared is equal to 3/4. Again, I need to make sure that I undo that square. So I'm going to square root both sides. I now have b is equal to radical 3 over radical 4, which is radical 3 over 2. Radical 4 turns into 2. Okay, so right here, radical 3 over 2. Okay, so this is my 30, 60, 90 triangle crash course, right? Of course. Again, remember, how do I make sure that I recognize these? Radius is always 1, which is my hypotenuse. Both of the hypotenuse is always 1. Here, this is a isosceles, which means identical or congruent legs. Radical 2 over 2 is the measure. Here, there's a relationship of a scale factor of 2 or half. So that means across from 30 or across from pi over 6 is always going to be half. Your shorter angle is always going to be half, okay? So your shorter angle is always going to be half. Your longer angle is going to create this side that's radical 3 over 2. We need to memorize these. This is going to make life so much easier, okay? Let's go ahead and now do a little quick crash review. Part 2 of my review, Sohcahtoa. So Sohcahtoa is actually what tells you what this is. So I'm looking at sine of theta angle, right, is equal to opposite over hypotenuse. So notice that's where you're getting the so from. Sohcahtoa sine is equal to opposite over hypotenuse. That's the so. Cosine of whichever theta I'm looking at is going to be adjacent over hypotenuse. So that's my ka. Again, cosine is adjacent over hypotenuse. And lastly, I have tangent of theta is equal to opposite over adjacent. So these are very important trig ratios. Okay, Sohcahtoa applies to right triangles. So there has to be a right angle in that triangle for this to work. Okay, so again, let's go ahead and see a couple of these so you understand what I'm trying to do. So I'm going to call this pi over 4, pi over 4. And then I'll call this one here pi over 6, pi over 3. Okay, my radius is always 1. Let's go ahead and name these sides. Again, this is radical 2 over 2, radical 2 over 2. If you noticed, I am now just calling them through the radian now. And so remember, across from pi over 6 is always going to be half. Okay? And across from pi over 3 is always going to be radical 3 over 2. Notice, again, across from pi over 3 is always radical 3 over 2. Across from pi over 6 is always half. So, let's say I want to find sine of pi over 4. Again, theta is your angle. So That's what I'm looking at, okay? Theta is your angle. That's your input into this little equation. So sine of pi over 4, which means I look at my sine of pi over 4. This is not my perspective. And I'm going to do what the rule tells me to do. Opposite over hypotenuse. So I have radical 2 over 2 over 1. So I know that sine of pi over 4 is equal to radical 2 over 2. Let's do one more. Sine of pi over 3. So pi over 3 is over here. This is now the perspective I'm taking. And I'm going to go opposite over hypotenuse. Again, opposite over hypotenuse, which gives me radical 3 over 2 divided by 1. So I know that sine of pi over 3 is equal to radical 3 over 2. Okay. If you want to make sure that you recognize this still, so that's 45 degrees, that's 45 degrees. This here is 60 degrees, this here is 30 degrees. So I just said sine of 45 degrees is equal to radical 2 over 2. Sine of 60 degrees is radical 3 over 2. Now, if you don't believe me, let's go ahead and do a quick little thing. My calculator, so I'm going to go ahead and look at my calculator. Notice that I went into mode, and my calculator is in radians. So I'm not in degrees, I'm in radians. That's why I'm going to be using my pi over 4s or my pi over 3s, etc. So I'm going to go sine of, my parentheses already there, pi divided by 4, close the parentheses. It's going to give me 0.707. Let's verify that radical 2 over 2 is 0.707. So I'm going to go radical 2, and then I'm going to divide that by 2. Did I get the 0.707? Bam, it's true. Let's see this one now, pi over 3. So I'm going to go sine pi divided by 3. It's going to give me 0.866 something. Well, let's see if that's that number right there. Radical 3 divided by 2, 0.866. So that's also true. So what did I just prove? Sine of the sine function, or the ratio that gives me opposite over adjacent of any 45-45 triangle is radical 2 over 2. And that same ratio, sine ratio for a 60-30-90 triangle, but only analyzing the angle 60, is radical 3 over 2. Okay, one more. Let's look at sine of pi over 6. So again, now this is my angle of reference, pi over 6, and I'm going to go opposite over hypotenuse. So that gives me 1/2 over 1. So I know that sine of pi over 6 is equal to 1/2. What is it? What does this mean? I just said that sine of 30 degrees is 1/2. Again, let's prove it. Sine, pi over 6. Look at that, 0.5. Cool. So we recognize some of those. Let's go ahead and do some cosine analysis. Your homework this week will also have cosine. Cosine is adjacent over hypotenuse. So I have cosine of pi over 4. So pi over 4, now I'm going adjacent over hypotenuse. Radical 2 over 2 divided by 1. So I know that cosine of pi over 4 is equal to radical 2 over 2. Let's do cosine of pi over 3. Pi over 3, now cosine means adjacent over hypotenuse. That gives me 1/2 over 1. So that means that I have cosine of pi over 3 is equal to 1/2. And cosine of pi over 6, so now here, adjacent over hypotenuse, it's going to give me radical 3 over 2 over 1, which means that cosine of pi over 6 is equal to radical 3 over 2. So what does this mean? Cosine of 45 degrees is radical 2 over 2. Cosine of 60 degrees is 1/2. And cosine of 30 degrees is radical 3 over 2. Okay? Oops. Right there. It's important that we recognize all of that because now we're going to combine them together. Now we're going to put all of this information into the unit circle. Okay. So I'm going to draw my unit circle. And I'm only going to focus on my first quadrant. Okay. Only going to focus on my first quadrant. Okay. And I'm going to draw those special triangles just here. So let me just quick little sketch. I'm going to start with my 45/45 or my pi over 4. Okay. This on my unit circle is always 1. That means that this triangle right here, theta here, is pi over 4. And I have radical 2 over 2 here and radical 2 over 2 here. Now remember that we are back to using a grid system, right? Our coordinate plane. So that means that this point right here has a coordinate point of, well, let's see. It took me this distance to get there and this distance to get to that point. So that distance is radical 2 over 2, comma, radical 2 over 2. Okay? So that theta right there is pi over 4, which means that this right here is also pi over 4. Again, remember triangle, angle, sum theorem. And for sake, I'm going to also put 45/45, just so you understand what that means. So this theta right here, this point right here is when my theta is pi over 4 or 45 degrees. Okay. Now I'm going to also draw another guy. I'm going to draw the 60. Get another. Maybe I'll do him blue, light blue. So remember, my 60, here it is. Now this theta is pi over 3. So this theta here is pi over 3 or 60 degrees. Remember, and this, don't think it's from here to here. It's from here to here. I'm just overlapping them so you can see. Okay? So this is always initial for all of my triangles right here. Okay? In fact, when I'm gonna be actually extending this over to all the quadrants. Your triangle must have one of its legs on the x-axis. That's one of the rules. So again, remember, pi over 3 means across. This one right here is pi over 6. Cross from pi over 6 is always 1/2. So this distance right here is going to be 1/2. And this distance right here, so is going to be radical 3 over 2. And my hypotenuse is always 1 because it's the radius to this unit circle. So that point is going to be 1/2 radical 3 over 2. Let's see. It took me 1/2 to get there and radical 3 over 2 to get there. So that point right there that's the coordinate point when my angle is pi over 3. Let's look at one more. And I'm going to look at this guy. So this theta here is now pi over 6. Remember, pi over 6 means that this is 1/2. And this over here is pi over 3, which means that's going to be radical 3 over 2. So this point right here is going to be, took me radical 3 over 2 to get here and 1/2 to get there. So this is going to be radical 3 over 2, comma 1/2. And that's for theta being pi over 6 or 30 degrees. So notice I have those triangles right there. Let's talk about something. Let's review. What was sine of, we'll go in ascending order. So what was sine of pi over 6? Well, that's pi over 6. opposite over hypotenuse, and each of these has a hypotenuse of 1, equals 1/2. Awesome. What was sine of pi over 4? Pi over 4, opposite over hypotenuse, gave me radical 2 over 2. What was sine of pi over 3? Well, this is pi over 3. Pi over 3 is opposite over hypotenuse. That gives me radical 3 over 2. What can you tell me about my coordinate system? Let's see. Pi over 6, I had 1/2. Pi over 4, I had radical 3 over 2. And pi over 3, radical over 2, radical 3 over 2. So if you noticed here, my little coordinate systems, my x and my y, this right here is sine theta. Let's see if it works for the other ones. What's cosine of pi over 6? Let's see. Pi over 6 is right here, which is adjacent over hypotenuse. Radical 3 over 2. Cosine of pi over 4. So pi over 4 is adjacent over hypotenuse. Radical 2 over 2. And cosine of pi over 3, adjacent over that, gives me 1/2. So let's see what that gives me. Cosine of pi over 6 is radical 3 over 2. Cosine of pi over 4 is radical 2. Cosine of pi over 3 is 1/2. So that gives me cosine theta is my x and sine theta is my y. Okay? It's really important to understand. But now I'm going to go ahead and extend this. So I'm going to start with my 45. That's the easiest one to look at. So this guy right here is my pi over 4, right? Half of it, 45 degrees. We recognize that this is 90 degrees. This right here is 180. This right here is 270. And then we're back to 60, right? And I can also say this is pi over 2. This is pi. And this is 3 pi over 2. And that's 2 pi. Okay. Watch what I'm going to do. I'm going to go ahead and reflect that homie. Okay. I'm going to reflect him over here. So now, this guy right here, I just reflected it. And this is pi over 4. Hypotenuse is always 1. But now, this length here is a negative. So now I have a negative radical 2 over 2 because it's on the left side of my x-axis. So these values are negative. But this is still radical 2 over 2, but it's just on the negative side. This guy's still positive. It's still above the x-axis, so it's radical 2 over 2. But let's talk about this angle, because this angle is no longer pi over 4. Remember, this is pi, and this, so if this is pi, and I'm taking away pi over 4, this is now, my theta here is 3 pi over 4. Okay, which means that if this is 180 and I took away 45, then this angle right here is what? 135. Think about it. 180 minus 45, 135. So my theta here is 135 degrees. So remember those terminal, this angle right here is 135 degree, right here. But we always reference against x-axis. So the triangle that I'm using is this guy right here. But the angle I'm still looking at is that guy. Okay? So I have a negative now. Okay, let's try to reflect the other guys. I'm going to reflect. And I apologize, my triangle's a little, it's just a sketch. Okay? So notice if I reflect it, my y coordinate is going to stay the same. It's just the x coordinate that changed to negative. So I have negative 1/2 radical 2. And this now, so if this is 180 and I took away 60, I'm at 120. And 120 is twice of 60. So that's going to be theta is equal to 2 pi over 3. Okay? So this right here is 120. Oops. And I'm going to do the same thing for the last one. This guy right here. reflecting him. So now this is, again, this angle right here is pi over 6, but I'm referencing it from this x-axis. So 180 take away 30 is 150. So I know my theta is 150 degrees, but if I'm looking at it in terms of pi, pi is 6 pi over 6. Take away pi over 6 gives me 5 pi over 6. 5 pi over 6. Okay? So what's that going to be now? Remember, only my x value, because it's a reflection against the y-axis. Y value stay the same. X coordinate value changes to negative. So I have negative radical 3 over 2, comma 1/2. Notice I just built that way. I'm going to do the same thing this way now. Reflect it this way. So start with this guy. He's being reflected. So now if I'm just looking at this, only my y coordinate is going to change negative, but I'm going to keep this one. This is the one I'm checking, okay? And it's going to be 180 plus 30, because now this theta right here is pi over 6, which is 30 degrees. So that's going to give me 210 or 7 pi over 6. So this theta right here for this point is going to be negative radical 3 over 2, negative 1/2. And this theta is going to be 7 pi over 6, or what's on 180, or 210 degrees. Okay? My 45. No, triangle should have been like that. There we go. My 45. Again, I'm going to use this one because I'm reflecting on the x-axis. My y-coordinate is going to turn negative. So I have negative radical 2 over 2, comma, negative radical 2 over 2. And this here is going to be 180 plus 45, which is 225. Theta here is 225 degrees, or let's see, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 radian. Okay. Building this next one here. Okay. See how I'm building it? You're going to have to practice this. You're actually going to recreate this in your homework. So again, I'm going to look at this one now. My coordinate points are going to be negative 1/2, negative radical 3 over 2. And this theta here is, let's see, that's 60 degrees. This right here is a 60 degree. 180 plus 60 is 240. Okay. Or I can look at it like this. 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Okay. Now I'm going to do the same from this third quadrant. I'm going to reflect into the fourth. Okay, so start with the last one I touched. So now all I'm doing is I can either use this triangle here or I can use this last triangle that I have. So whichever one, I'm just going to, the x value is going to turn, because I'm using y, it's the x value that I'm switching. If I'm going like this, I'm not touching the y-axis, the y value. I'm only switching the sign of the x value because I'm going from a negative x to a positive x. So it's going to be 1/2, comma, negative radical 3 over 2. And let's talk about this. This right here is a 60. So 360 degrees minus 60 is 300. So theta here, we put theta is equal to 300 degrees, or 12 pi over 6, right? I mean, sorry. 6 pi over 3. Take away pi over 3. 5 pi over 3. Let's go with our 45 or 140. Okay. Remember, my legs must always be against, one of the legs has to always be against the x-axis. So now this guy right here is going to be positive radical 2 over 2, negative radical 2 over 2. And here, my theta, let's talk about this. This is 2 pi theta, which is 8 pi theta, 7 pi over 4. 8 pi over 4 is 2 pi. Take away 1, it's going to give me 7 pi over 4. Or what's 360 minus 45? 315 degrees. And my last one. Okay, so this one's going to be radical 3 over 2, negative 1/2. Again, this is 30 degrees, so 360 minus that is 330 degrees. Or 12 pi over 6, take away pi over 6, 11 pi over 6 radian. You must know all of these coordinate points with both degree and radian analysis. So why is this important? Let's look at something. I have here all sine and cosine are positive. Over here, only sine is positive, but cosine becomes negative. Over here, in these angles, both sine and cosine are negative. And over here, in these angles, sine is negative, but cosine is positive. This is really important. You're now able to pinpoint. If I ask you, find me an angle that has neither sine nor cosine positive. So I'd be looking at an angle that's in this region, because in this region here, both sine and cosine are negative. So if you noticed, all are positive. Over here, cosine is negative. Both, so all are positive, none are positive. All are positive, none are positive. Over here, cosine's negative, sine's negative. So you need to understand this right here. Okay? Please complete your practice, and I hope you are safe. Have a good day.